need to register multiple FastMCP components at once without repeating decorator calls everywhere. You'll see how to encapsulate all your tool and resource registrations inside a single class, where the methods automatically register themselves when you create an instance. This pattern keeps your component setup clean, organized, and tied directly to object initialization.
From FastMCP, import FastMCP. MCP equals FastMCP. Class component provider. Definite self-MCP instance. Hash register methods. MCP instance, tool self tool method. MCP instance, resource data self, resource method. Def tool method self x. Return x2. Def resource method self. Return resource data. Hash the methods are automatically registered when creating the instance. Provider equals component provider, MCP.
This demonstrates the late binding registration pattern for integrating class methods with external systems, rather than decorating methods directly, which would capture unbound functions and expose implementation details like self to callers. The code registers methods after instantiation, ensuring proper binding and clean interfaces. The distinctive aspect is how it maintains object-oriented encapsulation while providing framework-compatible callables. The pattern works by deferring registration until object initialization, when methods become properly bound to their instances. This separation of concerns lets you design classes naturally while the framework interacts only with fully formed callables, never seeing internal parameters like self or CLS. It's a declarative approach that keeps registration logic co-located with the methods themselves without requiring external setup code. This approach solves the common problem of framework method incompatibility, where decorators and instance class methods conflict. It's particularly valuable for RPC systems, AI tooling, or plugin architectures, where you need to expose methods without leaking implementation details. The trade-off is slightly more explicit registration, but the benefit is robust, maintainable integration between OOP and functional frameworks. Let's break it down.
From FastMCP, import FastMCP.
This imports FastMCP, the core class for registering Python functions as AI callable tools. It handles the bridge between your code and AI models, managing serialization, validation, and execution.
MCP equals FastMCP.
Instantiates the core FastMCP controller. This single instance manages all tool registrations, resource handlers, and AI model interactions throughout the application. The pattern ensures centralized coordination of components.
Class component provider. Definite self-MCP instance. Hash register methods. MCP instance, tool self tool method. MCP instance, resource data self, resource method.
This implements automatic method registration during instantiation. The constructor binds tool method as an AI callable tool and resource method as a resource provider, eliminating manual registration. This is the dependency injection pattern for FastMCP components, ensuring all methods are available immediately after object creation.
Def tool method self x. Return x2.
This is a simple tool method that doubles its input, demonstrating the basic pattern for AI callable functions. The single parameter x and return value form the implicit schema that FastMCP exposes to AI models, with type inference handling the conversion between Python and AI representations.
Def resource method self. Return resource data.
This defines a resource provider method that returns static data. In FastMCP's component system, Resource methods serve as data endpoints, enabling AI tools to fetch predefined information without executing logic. The string return value becomes the resource payload when accessed via the registered resource//data URI.
Hash the methods are automatically registered when creating the instance. Provider equals component provider, MCP.
This instantiates component provider, triggering automatic registration of both the tool and resource methods with FastMCP. The pattern eliminates manual registration steps, ensuring all components are available immediately after object creation. This is the constructor-driven registration pattern, where initialization handles all setup. Component registration pattern. This example demonstrates FastMCP's class-based component registration, where instance methods are automatically bound and registered during object initialization. The registration happens in init before the instance is fully constructed, so avoid referencing uninitialized attributes in your registered methods. This pattern cleanly encapsulates related components while maintaining proper method binding for FastMCP's execution model.
The instance that registers itself disappears into the registry, yet its methods answer every call.